Descartes' rule of signs allows us to see the number of possible positive and the number of possible negative real zeros we could expect our polynomial to have. See, we're really used to referring to all possible zeros by taking the factors of p, the factors of q, and the factors of p over q. And sometimes this list can get really lengthy, and we need a way to say, what number should I even start with from a giant list of numbers to test as a zero? Well, this rule helps us just a little bit. And what we do is we say, well, how many sign changes do I see between f of x? And then in a moment, we'll look at the sign changes between f of negative x. So here I start with a positive 4. I stay positive. So I stay positive. I'm still positive. I'm still positive. I have no sign changes here. Therefore, because I have no sign changes, I would expect 0 possible positive roots, or we could say 0. So no positive zeros. But let's look at f of negative x. f of negative x would be 4 times a negative x to the 5th plus 6 times a negative x cubed plus 2 times negative x squared plus 6. Now, before I do anything, I want to clean this up. We know that when we have an odd degree, like here, a 5th degree, that this will stay negative. So it's really still going to be a negative x to the 5th, but I'm pulling that negative to the front. Similarly, I'd have minus 6x cubed because 3 is odd. But here I get to have plus 2x squared because negative x times negative x is x squared. And then I have my plus 6. Now, sign changes. I have negative to negative. Here is my first sign change. I went from negative to positive. And then I stay positive. So I only saw one sign change. So one sign change by Descartes' rule of signs indicates that there are one possible negative zero. We can use Descartes' rule of signs to find the possible positive and negative real zeros. But to begin with g of x, what we want to do is we want to first write this in the order that we know is proper here, which is minus 5x to the 7th plus 8x to the 6th plus 3x to the 5th minus x squared minus 3x plus 1. Because I want to have the leading term have the highest degree. So now, when I look at sign changes, I see that I go from a negative to start to a positive. I stay positive, and then I turn negative, stay negative, turn positive. So I can see here that I have 3 sign changes. And by that, I know that I'm going to have 3 or 1 positive 0. Now notice that I said 3 or 1. That 1 is 2 less than 3. So we always want to subtract by 2 from our highest starting number until we hit 0. Let's see what happens when we take g of negative x. This is going to be equal to, we've got negative 5 times negative x to the 7th, plus 8 times negative x to the 6th, plus 3 times negative x to the, 5th, minus a negative x squared, minus 3 times a negative x plus 1. Now I just want to check that I put my negatives everywhere that I needed them. And okay, now let's clean up. I know that an odd degree, like 7, is going to keep that as negative x to the 7th. But the two negatives, this negative and that, make it positive. So I've got a 5x to the 7th. I've got a plus 8x to the 6th because of 6 being even. And then I have a minus 3x to the 5th. I've got minus x squared because when I square this, it becomes positive, but the minus is still there. And then I have plus 3x plus 1. And actually, yes, we are good. Okay, let's look at sign changes. I am positive to start and I stay positive, change to negative. Stay negative, change to positive. Stay positive. I have 2 sign changes, which means I would expect 2 or 0, meaning none, negative zeros. And this is how we use Descartes' rule of signs.